Hello guys, so today I'll be solving this problem. So the problem is based on it's basically a implementation type of problem. Okay, so this kind of problem we call it implementation type. Okay, now the problem basically states that we have been given some n cars. Okay, now for each of this car there is some direction attached to them. Okay, and that direction basically designates let's say direction of the ith car. It basically designates in which direction the car is moving. Okay, it can be on the it can be moving on the left side, or it can be moving on the right side, or it can be stationary. Okay, so yeah, so for this they have designated LRS. Okay, now the another information is all of them are moving at the same speed. Okay, so there is no acceleration is happening. Okay, so same speed. Okay, now since cars are moving in different directions, okay, there will be collisions happening, right? So they have given some rules to how to calculate those collisions. Okay, so when two cars moving in the opposite direction collide with each other, the number of collision increases by 2. Okay, so basically if a car is moving on the right direction, okay, and a car is moving on the left direction, okay, then there will be collisions, right? Cool. Now another case of collision is when a moving car collides with a stationary car. Okay, the number of collision increases by 1. Okay, so this is one case. And then the second case is, let's say this car is moving on the right direction and it hits a car which is not moving, is stationary. Okay, so this is one type of collision. And the third collision is like we have a stationary car and a car is moving in the left direction and it gets collided. Okay, so yeah, these are the cases of the collision, and the question states that after a collision, the cars involved can no longer move, okay, and will stay at the point where they have collided, which basically means those cars which have collided, they become our new stationary cars. Okay, now in the end we just need to return the total number of collisions will be happening. Okay, number of collisions. Okay, so yeah, that's the goal. Okay, now let's think. Okay, so in this kind of implementation problem, you simply need to do what the question is asking. Okay, so the idea is you just uh, iterate over all the direction from left to right. Okay, and have some checks for your current iteration or for your current direction of the cars. Okay, so it's a very naive way of implementation, and but it works. Okay, cool. So what we will be doing is, so we will be iterating over all the directions. Okay, so let's call C in directions. Okay, and before that we will be keeping some counts for our left and right cars. Okay, for our like left moving cars and right moving cars. Okay, that we have encountered till now. Okay, for my current iteration. Okay, like before my current iteration. Okay, so I'll say the number of left cars I have visited 0, the number of right moving cars I have visited 0. Okay, another thing that we will be needing is the whether we have gotten a stationary car. Okay, so I'll be setting it to 0. Okay, now why I don't need to set the set the count of my stationary car, because let's say I have these kind of condition. Okay, let's say 3 cars are moving in the right direction. Okay, and let's say 2 cars are moving in the left direction. Okay, then what will happen? Okay, these 2 cars will collide. Okay, they will become stationary. Okay, now this car will collide with this car. Okay, and also this car will collide with this car. Okay, now after this collision, this and this will become stationary. Okay, now finally this car will come and it will get collided with this stationary car. Okay, so with that way we will get all stationaries. And yeah, so basically having stationary car, okay, or the number of stationary cars that I am having, it doesn't gives me anything. But if I know the information that okay, I'm getting a stationary car, okay, that is just enough. Because if I have encountered a stationary car, okay, and for some iteration, let's say for some ith iteration, I'm getting a car which is moving in the left direction, okay, so this guy will be colliding with this guy only, okay. So it doesn't matter whether I have stationary cars before this guy, okay, this guy will only collide with the immediate stationary car, right? So simply setting s as a bit flag 0 or 1, okay, will work, okay. So yeah, so the idea is I will be iterating over all the direction, okay, then I'll check if my current direction is r, okay. So what does this imply, okay, if my current car is moving in the right direction, okay, so if I have cars which are moving in the left direction, will they collide? Nope. If I have the, if my like stationary flag is set, okay, which basically means I have encountered a stationary car, then will they collide? Nope, right? Because this guy is moving away from my stationary car, so they will not collide, okay. Then the third case is, let's say I have another car which is also moving in the same right direction. Now, will they collide? No, right? Because they are moving in the same speed, okay, so they will never collide, okay. So what I will do here is I will simply increment my answer by +1, okay. Then let's say my current iteration, okay, in my current iteration I am getting L, okay, a car is moving in the left direction. So what will happen, okay, let's say I have some left counts, okay, some cars which are already moving in the left direction. Now this guy is also moving in the left direction. I will not encounter any collisions, right, because of this same logic, because all of them are moving in the same speed, okay, cool. But if I have some cars which are moving in the right direction, okay, let's say I have some cars which are moving in the right direction. Now because of this guy which is moving in my current left direction, the immediate car which is moving in the right direction will get collided with this guy, okay. In so in that I will have a check if I have some certain number of cars which are moving in the right direction, okay. So in that I'll simply increment my answer with +2, okay, as per the question only, right, okay. So I'm not moving away from the question, I'm just doing what the question is saying, okay. So yeah, I'll increment my answer by +2, okay. But these two guys will be colliding, okay, and they will be become stationary. What will be happening to these guys, okay, because they are also moving, okay, in right direction, they will get collided with their immediate stationary guy, okay. So whatever cars I have before this guy, okay, which are moving in the same direction as this guy, they will get collided, okay. So what I will do is, since this guy has already collided with this current guy, okay, so I will decrease my R count, okay, because this guy has become stationary, okay. Now whatever car are still moving in my right direction, okay, I'll simply add them up with my answer, okay. Now after that, since I have consumed all the cars that are moving in my right direction, okay, I'll be setting my R count as 0, okay, cool. Now this is for this case. What will happen if if my stationary flag is set, then that means this guy will be colliding with this guy, right, because this guy will be coming towards this guy and it will be colliding, okay. So in that case I'll check if, or let's say else if, my stationary flag is set, okay, that means I have a stationary car, okay, then this guy will simply collide with that. So in that case I will increment my answer by +1, okay, same as what is written here, okay. If a moving car collides with a stationary car, the number of collision increases by 1, okay. Then what will happen, okay, so I simply need to do this. Otherwise, okay, I'll simply increment my left count, okay. So I'll say else, okay, left plus plus. Now one more thing you should observe is, since cars are colliding, okay, that means we are getting stationary cars, right, okay. So I can simply set s equal to 1 here, okay, and s equal to 1 here, okay, because these are like my colliding condition, and after the collision I will be getting stationary cars. Okay, that means my stationary flag should be on after this. Okay, cool. Then after this I'll say my final condition is if my current character is S. Okay, so what will happen? Okay, if my current character is S, okay, and let's say the first case, if I have some cars which are moving in the left direction, okay, no one will collide with this point, right? Because all of them are moving away from this point. Okay, so yeah, I don't need to care about left moving cars. Then if I have some cars which are moving in the right direction and I am encountering a stationary car in my current iteration, that means all of them will collide. Okay, so I need to take care of this condition. If I have some right moving cars, okay, then in that case, whatever be my right count, okay, I will simply increment my answer with that. Okay, and I will set this R as 0 because all of them will be consumed because they will be colliding. Okay, cool. Then the third case is I already have a stationary car and now this guy is also stationary car. Now both of them are not doing anything. Okay, they will be maintaining their own inertia. Okay, so that means I will simply set S equal to 1. Okay, cool. Now with this logic, okay, we should be able to solve this problem. Okay, so if I simply implement this solution, okay, here, so I'll be setting L equal to 0, R equal to 0, S equal to 0 initially. Okay, then I'll be iterating over all the direction in my string. Okay, so I'll say if C equal to R. Okay, so in that case what we are doing, we are simply incrementing my R count. Okay, R plus plus. Okay, else if, okay, if C equal to L, then I need to take care of the collision conditions. Okay, so if R is more than 0, okay, if I have some right moving cars and my current car is L, then I'll simply do this step by step calculation. Okay, so the first immediate right car will get collided with this left car, so I'll increment my answer by +2. Okay, then I'll be decreasing my right count, okay, because that immediate car has collided. Then whatever right cars I have, okay, those will be colliding my with their immediate stationary car. Okay, like what we have discussed here. And then I'll be setting my R count as 0 and S flag as 1. Okay, because after that I will be getting some stationary cars. Cool. Then if I have encountered a stationary car, then this car will be moving towards this stationary car and it will get collided. Then in that case I will simply increment my answer and I will set S equal to 1. Okay, otherwise I will simply increment my L. Okay, cool. Then the final case, if my current character, or let's say if my current character is S, okay, then in that case I'll simply need to take care of the right moving cars because those cars will be moving towards this stationary guy. Okay, so I will simply say if R count is more than 0, okay, I'll simply increment all my answer by all the right moving cars and I will be setting them. Okay, then I will simply set my like stationary flag as 1. Okay, because after this, okay, I'm getting a stationary car and even if collision is happening I'm still getting a stationary car. Okay, so I will simply set this flag. Okay, then I will return my answer. Yeah, so I need to initialize my answer. Okay, cool, all task is passed. Now let's submit. So we are in the top lead, but as I said, never trust this graph. Okay, now instead of doing all this, okay, we can also have a simpler implementation. Okay, this thing will work if I compute the time complexity of this. Okay, this will be what, big O of the number of characters in the direction, right? So basically big O of n, because after that all of them are like constant time operations. Okay, and here we are not consuming any space complexity, right? So yeah, this code will work. Okay, but let's say you are in an interview, okay, and the interviewer doesn't like all this if else condition because these things are prone to make bugs, right, in the code base. Okay, so we should always think of simpler implementation. Okay, Now there is another way to look at this problem. Okay, let's say I have a test case something like this. Let's say I have some cars, LLL, RL, SL, RL, and let's say after that I have RRR. Okay, let's say I have this kind of a condition. Okay, so if you look at this initial car, all of them are moving towards left. Okay, and there is no right car here in front of them, right? Okay, so I can simply trimmed off this part of my direction string. Okay, cool. Similarly for the end, okay, these car moving on my right directions, right? Now they do not have any left car here, which basically means they will never get collided and they will never contribute to my answer. Okay, so I can simply trimmed off this parts on also. Okay, now so that means my region of interest will only lie between in this segment. Okay, now let's see how can I easily compute my answer. Okay, so I have this thing. Okay, now what I have, so I have RL. Okay, these two will be colliding. Okay, then I have an S and L. Okay, this two will be colliding. Okay, now then I have this R and L. Okay, these two will also be colliding. Okay, so the number of collisions I'll be getting is like 3 collision, and in each collision I have 2 participants, which basically means 6. Okay, now let's say instead of this segment I have something like this. Okay, let's say I have RSL, let's say RL SL, let's say. Okay, now if I look at here, okay, I have RSL, which basically means I have a car which is moving in the right direction, and I have a stationary point here, and I have this L which is moving in the left direction. Okay, so I'll be having 2 collisions, right? So here I will be incrementing my answer by +2. Okay, if I only look at this segment. Okay, now if you think more deep, okay, you'll observe that you don't actually need this S. Okay, basically what I'm saying is, if you have a case of RL also, okay, then also you need to increment your answer by +2, right? Also if you have multiple S here, okay, then also there are only 2 cars which are participating in the collisions. Okay, so the number of participants in the collision doesn't vary with S. Okay, now if you observe this, okay, or maybe yeah, this case, okay, so the S points, if you simply remove them, okay, so it will become R L R L L. Okay, all of them will be colliding with each other. Okay, so having S in this segment doesn't really matter. Okay, so the idea is pretty simple here. Okay, you simply trimmed off all of your non-colliding cars. Okay, now with whatever segment you are left, okay, you can simply count the number of R's and L's you have in those segment, because S never participates in collision. The only R's and S will be participating in this in those collisions, and those will be contributing to your answer. Okay, so the idea is find the segment, okay, or find the maybe colliding segment. Okay, and how to find this is basically trimmed off your non-colliding cars. Okay, now whatever segment you are left with, okay, simply count the number of R's you have and the number of L's you have, because those cars which are moving in right or left direction, only those will be participating in the collision, and those will be contributing to your answer. S never contribute to your answer. Okay, so yeah, so that's the logic, and let's quickly implement this. Okay, so yeah, yeah, so same thing, but I'll be removing this. Okay, so and I'll be needing the direction size for n, and I'll be initializing r as n minus 1. Okay, so the idea is first trimmed off all the consecutive else you have, okay, because in your start, okay, because they will never collide, right? So I'll say while L is less than N, okay, and the directions of L is equal to L, okay, I'll keep on incrementing my L, okay. Then I'll be trimming off this part, which basically means while R is greater than equal to 0 and my direction is keep on giving me R, okay, then I'll be decrementing my R count, okay. After this, my L and R will get to these points, okay, this segment L and R. Now here in this segment I only need to count the number of R's and L's I have, okay. So basically for int I equal to L, I less than equal to R and I plus plus, okay, I'll increment my answer, okay. For non-S character you can also think of, okay, if directions of I not equal to S, okay, this will simply give me the number of R's and L's, right? Okay, if I simply remove all the S. Cool. So now let's check for test cases. All test cases pass. Now let's submit. And voila, it works. Now this is a pretty simpler implementation, right? And it's not prone to bugs, right? Because only 10 lines of code, right? Now let's do the same thing for Go, okay. So I'll be creating LR and ans. So LR ans, I'll be saying L as 0, R as n-1 and answer as 0, and before that I will be needing the total number of characters, so which is len of directions, right? Then I'll be incrementing my L first, okay. So L as an n and directions of L equal to L, okay. I'll keep on incrementing L. So this is trimming off the consecutive L's that you have, right? So yeah, then same thing but for R's. So R is greater than equal to 0 and you are keep on getting R's on your right side, R. Then you will be decrementing your R. Then with whatever segment you have right now, simply count the L, I less than equal to R, I plus plus, oopsie, okay. Now if rune of I need to use rune, yes, rune of I is not equal to rune of S, I'll simply increment my answers, okay. Yeah, then here also I need to use rune. I can do something like this, okay, and this is a pattern. I can use rune here also, okay. Now if I check for all test cases, all test cases pass, let's submit. Voila, it works. Now let's finally do it for Rust. Now if you also think of time complexity, you are touching every character once, right? Like there are some loops, okay, to figure out this thing and this thing, okay, but every time if you think, you are touching only one character at a time, like all characters will be touched once, okay. So the time complexity will be big O of the number of characters, and since we are not using any space, so that will be constant, okay. So both of the approach are giving you the same time complexity, but this implementation is simpler, okay. So yeah, so in Rust I'll be creating L as 0, and similarly for R as 0. Then I'll be incrementing my answer, so that will also be mute, and yeah, I need to create N, which is directions of len, yeah. Then yeah, R will be stored as n-1, and this will be this. Then In Rust, there is so I need to convert this direction into bytes. Okay, so I'll say bytes, direction as bytes. Okay, cool. Now I'll be first streaming of the first consecutive else, so that means for, or I can use while loop here. Yep, while L is less than R and directions of L is equal to the byte representation of L. Then I'll be incrementing my L as plus equal to 1. Then similarly for R greater than equal to 0 and directions of R equal to B of R. Okay, so I will be decrementing R. Then after that I'll be getting the endpoints for my segment, so I'll be iterating over these. So I in range L R. Okay, I'll be saying if my, oh yeah, I need to use bytes here, right? Yeah, because you cannot directly do indexing with string in Rust. So yeah, I'll be using bytes. Bytes of I is if it is not equal to the byte representation of S, then I'll be incrementing my ans plus equal to 1. Yep. Then finally I'll need to return ans. Cool. So hopefully should work. Fingers crossed. Okay, all test cases pass. Let's submit. Okay, cool. We are getting an error. Okay, so direction is R, and which means, yeah, this guy will get decremented by 1, but R is U size, right? Okay, so R is U size and it's getting negative, and U size cannot be negative. So what I can do is I can either convert it into I32 or let's solve this base case. Okay, so if n equal to 1, okay, or maybe n is less than equal to 1, then that means I have only one car, right? Okay, so it is impossible to have collisions, right? So I can simply return 0 here. So yeah, after this it should work. Accepted. Cool. So yeah, this was the logic. So I have shown you these two logics. So I think this will first come into your mind when you start solving it, because it's pretty the naive way, right? Okay, but there are many conditions here, right? So go with a simpler approach. Just think a little more deep, okay, and just understand the problem, okay, and by that you will be reaching at this stage, okay. Like both of them have the same time complexity, but this is a much pretty simpler solution, right? Cool. So I hope you learned something new. If you like this video, please do like and subscribe to the channel, and just stay tuned to watch more videos. Thank you. Bye bye.